Hi and welcome to the Year 11 induction lesson for the A-level physics at Cheshire Grammar School. My name is Mr. Madej. I'm subject leader for physics here, so I'd just like to talk to you a little bit about the course. What is physics? So physics is a natural science that involves the study of matter and its motion through space and time, and there are also the related concepts such as force and energy, which allow us to understand how the universe behaves. There's a really interesting video that you could watch. It's on YouTube. I would just search for that title. So, The Story of Physics Extended Version by Daria O'Brien. It's only 4 minutes long, but it just talks about the history and development of physics as a subject. We won't watch it now, but I'd still like to talk to you about the course instead. So through the course, which is 2 years, you'll study these topics. So in year 1 of the course, or year 12, you'll study measurements and their errors, particles and radiation, waves, mechanics and materials, and electricity. So that will be what you'll study in year 12. In year 13, you'll do fields, which will include gravitational, electric, and magnetic fields, nuclear physics, further mechanics, which is circular motion and simple harmonic motion, thermal physics, and astrophysics. And they will be the ones you'll study in year 13. The course itself is assessed 100% by exams. So there'll be 3 papers you will sit at the end of year 2. Paper 1 is mostly the stuff that you'll study in year 12. Paper 2 is mostly the stuff you'll study in year 13. And paper 3 will cover astrophysics, which is the optional topic we do, as well as your practical skills. Now, through the course, you will do 12 required practicals, and it is those required practicals that will be assessed in paper 3. Okay, notice how each exam is also 2 hours long. The whole course is 100% exam based, and you'll have a mixture of short and long numerical and kind of describe and explain questions, and you'll also have multiple choice questions as well. Every lesson you'll need to bring with you a folder. So this folder will contain your class notes, exam questions that we have completed, any homework that you've done, any bi-weekly tests that we do, because you'll do a test every 2 weeks, and any further reading that you've done. You'll also have a folder, a document wallet, that we'll keep in the physics department. So every time you do a required practical, you have to write that up in full, and that will be kept in the document folder in the physics prep room. You also need to make sure that you always bring your data booklet. So in your GCSE, you had to remember all these equations. At A-level, you are given a formula booklet that contains all the equations you need, all of the constants. You just need to make sure that you can pick the correct equation to solve the current problem. You'll also need to bring with you every lesson a calculator. It doesn't have to be graphical. A scientific calculator is all you need for A-level physics. In terms of the resources, all of our lessons are on this resource we call Caboodle. Okay, so all of the lessons are on there. Plus, you'll get access to like a digital book. So that will be on Caboodle. Now, we don't use that book in class. It's just another resource for you to refer to. We teach the lessons in the same sequence as on Caboodle. You'll get the opportunity to purchase, which is a CGP textbook. Students prefer this. And we have class sets of these as well, so we can use those in class. We also use Isaac Physics. So this is a set of textbooks that we've got with problems, just problem-based, and it's a website with difficult or more challenging problems on there. At the start of the year, we'll create a class, you join that class, and then it will just track your progress as you work through these questions. So Isaac Physics is a fantastic online resource. And finally, there's past paper questions. So these will be used quite a bit. Generally in class, they'll be used to work through as worked examples. Possibly you'll work through them yourselves, but also for homework, quite often exam questions will be set for you to work through by yourself, so you can work and have a look at them next lesson. Now, I said earlier about bi-weekly. Every 2 weeks you'll do a test. It's only 30 minutes long. It will either be marked by the teacher or peer marked, and that's just, again, another just good indicator just how well you are doing, and keep you on your toes. And again, these practicals, there are 12 required practicals that you have to do that will be written up in full, but they're not the only ones. There are also practicals that we do as we go through the course, just to support your learning. So you can apply what you are learning, and it can hopefully show you the relevance of it as well. I often get asked this question: is A-level physics hard? How hard is A-level physics? I don't think that's really a question that you can answer. I prefer to think of it like this: it's a spectrum. So if you work easy, it's hard, but if you work hard, it's easier. So if you do the bare minimum and you just turn up to lessons, so I say that's working easy, you're not working hard, you'll make little progress, and 2 years later when it comes to exams, you'll probably find A-level physics is still hard. Whereas if you work hard, you turn up to lessons, you read notes, you complete all your work, practice exam questions, and you reflect on your work. If you're stuck, you ask for help and you read ahead. Maybe that's a specification or a textbook, and you read around the subject as well. It will become easy or easier. So if you work hard, you'll make excellent progress and it becomes easier. So it's up to you to what kind of student do you want to be. I got some feedback from previous students as well and asked them what their advice they would give new students. So this is some of what they said. So read around the subject, make sure you make good use of the book, start making notes as soon as possible, do not leave it to the last minute, make sure you do lots of past papers, make sure you get a B in science and math. The internet is an excellent source of information to help you. You can use past papers from other exam boards to revise early on. Do not rely on just the book, use other sources. I would recommend using a tutor over the holidays. That's up to you, there's no need for that really. And do lots of past papers to test your knowledge. So at this point in the induction lesson, we normally do a practical. What happens is I give you a party popper and I ask you the question, how many party poppers will it take to accelerate a 1,000 kilogram car to 1 meter per second? And I'll leave that up to you to kind of plan the practical how you could work that out. Unfortunately, in the current circumstances, we can't do that. So I'll tell you one way of doing that. So you get your party popper, you take out the insides, okay, so all the string in the card, and you place it vertically pointing upwards in a clamp stand. You then get a ping pong ball and you place the ping pong ball on the top of that empty party popper, and you also have in the clamp stand a ruler. So when you pull the string, that is going to make that ping pong ball fly vertically upwards. It's going to give it kinetic energy. So if we can record the height that that ping pong ball reaches, we know how much gravitational potential energy the ping pong ball has at its highest point, and we can assume that that potential energy, gravitational potential energy, must have been kinetic energy given to it by the party popper. And once you know how much kinetic energy it's got, you can work out how much kinetic energy a car of 1,000 kilograms moving at 1 meter per second must have, and therefore how many party poppers you would require. So here's a quick video of me kind of just doing one of those party popper experiments. Here we go. Let's play that. There you go. Okay, and the results. So the mass of the ping pong ball was 2.25 grams. I did 5 attempts, and they are the heights that I recorded. Okay, so the first thing you need to do is to work out the average height that ping pong ball went. Okay, so I'm not going to tell you anymore. I'll let you work that out. Okay, so that's a problem for you to try and solve now. So how many party poppers would be required to make a car 1,000 kilograms accelerate to 1 meter per second? Okay, so see if you can come up with a solution, and then hopefully when I see you in September, I can see what kind of answers you came up with. Okay, well, have fun, and I look forward to seeing you all.